Unit 2, Lesson 13, two graphs for each relationship. I can interpret a graph of a proportional relationship using the situation, and I can write an equation to representing a proportional relationship from a graph. All right, so I'm going to turn my drawing tools. So it says Andre and Jada were in a hot dog eating contest. Andre ate, this is the important part, Andre ate 10 hot dogs in 3 minutes. Jada ate 12 hot dogs in 5 minutes. On the first graph, label Andre's consumption and Jada's consumption. Draw two lines, one through the origin at Andre's point and one through the origin at Jada's point. Okay, so I've got to see who's eating faster. So I know that let me change back to yellow. The only reason I'm doing that is so that you guys can tell what I'm doing. So I know time is the x-axis, so it's going to go on this side. And hot dogs is going to go over here. So 3 and 10. So in 1 minute, Andre eats 1 and 3 repeating hot dogs. So 1.333. So then I'm going to change back to blue. And I'm going to do Jada. So time, again, is the x-axis. And the number of hot dogs is the y. So the time was 5 minutes. 12 hot dogs. So I'm dividing by 5. So she can eat 1.4. No. She can eat 2.4. And my math is wrong over there too. 2.4. So that means I was thinking about a normal person. So, yeah, 2.4. So that means that because his constant of proportionality is steeper or higher, that tells me that his has to be this one. Let's use let's just use my tool. Because it's a proportional relationship, I have to go through. I'm going to make that yellow. Okay, and then we have to draw a line through Jada's. So I'm going to make that one purple. So I hit the paintbrush to change the color. Or really, that's kind of like a blue color, I guess. There we go. All right, so then they say they want us to use, they want us to write an equation for Andre and use T to represent the time in minutes to eat H hot dogs. So I know that I'm going to multiply so the number of hot dogs is going to be equal to 3.3 times the amount of time, because he can eat 3.3 hot dogs in 1 minute, so I would multiply it by 2 minutes, 3 minutes, 4 minutes to get my answer. Okay, and I want to make that repeating. So then they want us to write an equation to represent the number of hot dogs Jada's eating. So I know the hot dogs are equal to 2.4 times the amount of time. So now it says Andre and Jada were still in the same contest. On the first graph, label Andre's consumption and Jada's consumption, draw two lines through the original. So if you notice, they changed the axes. So that's why the points moved. So I'm going to have to go back and do Andre and Jada again. So this time H, and this time this side's T. So I know that Andre ate 10 hot dogs in 3 minutes. So I want to figure out how long it took him to eat one hot dog. So I divide by 10, and I get 0.3. Now that's not repeating, it's just 3/10. So then I'm going to do Jada. So hot dogs is the X, time is the Y, because this is always my X, and this is always my Y. So 12 and 5. So I know this would be 1. So 5 divided by 12 in that order. So I'm going to use my handy dandy calculator. And I get a crazy number. 0.4167, whatever. I'll probably use the fraction in my equation. Okay, so it says, which graph is whose? So I know that I'm going to use my line again. Okay, I know that this has to be Andre's line because his constant of proportionality is 3/10. So that means it's going to be lower, I'm sorry guys, than Jada's. So I'm going to add another line for Jada's. We're still going through that origin. There we go. So I'm going to change that one's color to that bluey color we've been using. All right, so now they want us to write an equation using T for time and minutes to represent the number of hot dogs. So I know that if I'm doing Jada, I know the time is going to be 5/12 because I don't want to use this crazy number. So I'm going to use my fraction, 5/12 times the number of hot dogs. So it takes 5/12 of a minute for her to eat one hot dog. So then I would multiply that out. So now I'm going to do Andre. So again, it's going to be time equals, and it's 3/10, straight up 3/10, not repeating. So I don't need to use a fraction, times the number of hot dogs. So now it says, at any supermarket, you can fill your own Honey Bear container. A customer buys 12 ounces of honey for $5.40. How much is the honey per ounce? So if I want to figure out honey per ounce, I know this is my ounces, this is my money, so 12 for $5.40. I want to figure it out for 1, divide by 12, Then in my calculator, I'm doing $5.40 divided by 12, and I get 45 cents per ounce. So how much honey can you buy per dollar? I'm going to switch colors. My ratio stays the same, but this time I put the 1 in the dollars column. I'm dividing by 540. So 12 divided by 540. I get 2.2 repeating. So for $1, I can get 2.2 repeating ounces. So use two different equations to represent. Use H for honey and C for the cost. So I'm going to just take it one more row, and I'm going to put C here. So it would be 2.2 C would be the amount of honey. So honey is equal to 2.2 repeating times the cost. Okay, in the other one, I'm going to put my H here, so it's going to be 0.45 H. So C equals 0.45 H, because that's the expression that I got, and that's going to equal my cost. The point 3 6/5 lies on a graph in a proportional relationship. Select all the following points that lie on the same graph. So I know it's a select all, so it's going to be more than one. So I have to think I have 3 6/5. So I'm going to draw myself a table. I'm going to label it X and Y. So when X is 3, Y is 6/5. So I want to know what it's going to be when X is 1. So I'm going to change 6/5 into a decimal to make it easier for me to do my division. So 6 divided by 5 is going to equal 1.2. So if I want to get from here to here, I'm going to divide by 3. Shouldn't have said 5. 1.2. So then I'm going to divide this side by 3. So 0.4. So 1 equals 0.4. So that's going to be the first one. So then I would check every other one from there out. So my constant of proportionality is right here. So now I have to check each point against that. So I'm just going to do a lot of erasing so it doesn't look crazy and confusing. So I put 1.5 here, and I want to see if it equals 6/10. So I'm multiplying by 1.5. So I'm going to do 4/10. So 0.4 times 1.5, and I get 6/10. So this one's also correct. Okay? I'm only erasing it because I think it's going to get confusing if I keep all this stuff on there. So then 6/5, so we know that's 1.2 is equal to 3. Well, let's try it. Times 1.2, so 0.4 times 1.2 is 0.48. So that's no. So let's try another one. Okay, let me switch colors again. So I get 4 and then 11/5. So that's actually going to be 2 1/5. So that's 11 divided by 5, 2.2. So we're going to multiply this by 4. So then I'm going to multiply this side by 4. So 4/10 times 4 gives me 1.6. So that's out. Okay, and then I'm going to do my last one, switch colors one more time. So I've got 15 and 6, multiply by 15, multiply this side by 15, so 4/10 times 15. I get 6, so it does work. So A, B, and E are my answers. Now you've got to cool down about popcorn and money. If you're not understanding these equations, you're not understanding the lines, whatever, there are extra practice problems on Khan Academy. Mr. Morgan does another video of this, and he might be able to explain it in a way that makes more sense to you. You can talk to a friend or set up an appointment with me on Calendly. Just click the link.